Hi, my name is Evans and I'm a CRE at Replicated. I'm here to talk to you about how we use CMX clusters to support our customers. On a typical day, I'm usually responding to vendors through support cases that they raise in vendor portal. These support cases would usually be related to installing applications at customer sites, customer configurations of these applications, upgrades, and what have you. Now, some of these installation or upgrade or maybe configuration problems may be so challenging that we'd require to try and reproduce them locally or in our own test environments. This would take quite some time, naturally, because we have to create clusters, destroy clusters, install custom applications, try to create various configuration options of these applications. Now, in my suite of tools that I use, I have a number of vendor portal applications which are configured in a way that I can try to mimic how a customer's application would behave. I have a Helm app, an air gap app, and a COTS application as well, all with various manifest and configuration knobs that try to cover as much surface area of our product as possible. At the same time, I have VMs at my disposal, which I create and delete quite often, so as I can set up clusters such as curl clusters, kind, or what have you, for embedded cluster environments or cloud provided clusters. If I'd like to run a GCP cluster or rather GKE cluster, AKS, EKS, OpenShift, and would like to try to reproduce issues there. And up until recently, I started using CMX clusters, which is a product for creating clusters, various Kubernetes clusters that Replicated announced. Today, I'd like to demo a sample, troubleshooting a sample application on a CMX cluster to show how I do this. Whenever a case is raised, the first thing that you get to see is we ask from a vendor is a support bundle. Now I have one here, and the support bundle, this use case here that we are trying to look at is of a COTS application where admin console is running properly, but it's unable to deploy the customer's application. Now the customer's application in this case is simple Nginx board, which will be running, which needs to be deployed. Now that deployment is failing. Whenever we receive a support bundle, the first thing I do is check the overall health of the cluster. The support bundle contains Kubernetes manifests and various other files that are collected by support bundle binary at the customer side. Now, since we have the manifests here, we have a tool called spctl, which essentially starts a Kubernetes API server and surfaces the Kubernetes manifests as a read-only Kubernetes cluster. So I'm going to do that right here. Oh, before we do that, let's just check. So as you can see, there's no cluster running. Now we do that. Okay. And then check whether all pods are healthy. They look healthy, which is okay. That's nothing to follow up with regards to the health of a cluster. Now, since we know that admin console could not, or COTS-ADM could not deploy the application, customer's application, the next thing we do is check the logs of COTS-ADM. Logs, COTS-ADM, which would be that. Okay, we're seeing a bunch of errors, which is indicative of something going wrong. And as we look closer, we can see here that COTS-ADM was applying resources. So these are Kubernetes manifests, which are part of the customer's release. And at this point, as you can see, there's a pair of applying resource, applied resource, applying resource, but this fails. So this is a resource that's failing here. The rest did succeed. Now, my next step here is going to look at the customer's release. Now, the customer's release manifests are collected and they're in the support bundle, which we're going to take a look at in a moment. So here it is. Come in here. Admin console app. So it's a bit of a hierarchy. We open the customer's release, and we remember this was a resource called app config. There you go. Now, naturally, this would contain many more files, so it might be a bit of a process looking for what you'd like to find here, but eventually we end up finding it. So this is the config. This is a config that couldn't be applied. Now we can see it has some configuration options here, and what I would do immediately is try to deploy this in my own cluster. So assuming I couldn't figure out by just looking at this and figuring out what the problem is, I'll try to recreate this resource in my own cluster. Now, what we'll do is we are going to create a cluster in CMX. Replicated cluster, create distribution. I'll create an OpenShift one. And as it's creating, I can already show you various versions. As you can see, we have quite a number of them, AKS, K3S kind. And this allows me, using the same CLI, to create any kind of cluster without having to leave this terminal or trying to interact with various either vendor or cloud provider tools or interfaces. I just use the replicated cluster CLI. So now it's creating. Let's see. It's being verified. So as it's doing that, the next thing I would try to do is, or I intend to do in this case, would be create. So I took the liberty of creating a demo application here. And what I'd like to do now is create an application that would deploy this thing we are seeing here. Okay. We'll create a new release. So we know it's a COTS application. We're trying to create a config map. Just need to create some new resource here. Let's call it tests. Well, actually what we could do is use one of them that's existing, since this is a throwaway one. All right. And we have two configs here. What we'll do is come to the customer's config and collect those two configuration options, which are right here. Add them to my config file. All right. Let's create the release and then promote it to unstable. And I have a customer called demo customer, whose license is here. It's called test customer, I believe. No, demo customer. Well, actually, I don't have the license, but you know what? I'll just download the license. Download license. Let's move it. Let's move it here. So now I have the demo customer. Now what I'll do is, let's check whether my cluster got created. today. Thank you. Yeah, that took about a minute. And right here, we have our OpenShift cluster. So what I'll do is I'll install the customer's application here. And what we hope to see is the customer, I'll deploy my test application here. And what we hope to see is the same failure that we are seeing in this support bundle. Now what I'll do is replicate it. I'll launch a shell into the, I'll launch a shell which essentially fronts my cluster right here. I changed tabs because I have ephemeral running here, so I do not want to be within a number of shells in the same terminal. So replicated cluster shell this. So what this is doing, it's going to, just like ephemeral, it's going to launch a shell which exports a kubeconfig. And with that, it will download a kubeconfig, store it in this directory, and with that, you should be able to run kubeconfig, kubectl commands within that shell, as you can see. So it's quite nifty in that regard. And with that, I should be able to just exit that shell, and when I run that, I have nothing. So let's go back to that shell, and what I'll do now is I have a release here. It's right there, channels. I'll come and try and I'll install this application. Okay. All right. Let's install it into the default namespace, shared password. Let's call it my pass. Do not do this at home. So now this should install my admin console application. And as it's doing that, let's look at the release. So we have the release here, view release. It's right here. Now we can already see in vendor portal, linting is already pointing us to an issue with this specific configuration. There is a warning here. And when I'm looking at cases and see these kind of things, I do dig into this before I go on to create clusters. But let's do that so that we can get to see how the actual deployment looks like. It's right here, so it's progressing. Let's check. All right, we have it. I wanted to check whether it's failing because I do see some warnings here. All right, so now the next thing we'll do is go to admin console. Was it 8080? Yes, there you go. My pass. Okay, let's choose a file. Evans repos playground demo cluster. Upload license. Let's continue. So this is the process that it takes to try and create a customer's application. If I was launching a VM, which as I pointed out here, does take about 5 to 30 minutes depending on my setup, I'd not be this far by now. All right, let's deploy that. Do not ignore pre-flight checks, but let's do that. All right, now we see some deployment failures. Yes, this is what I was expecting to see. So yay. So the first check of is the application, are we still seeing the same problem as the problem that the customer is seeing in their environment? Yes, that checks. And we can even test that here. We can do that. Okay, get pods. This is our application. We can logs cots ADM 7. Yes, very similar. Here it is. So now we can tell this is a problem. It's the same problem that we are seeing at with the support bundle, in the support bundle that we received. Now the next thing which I would do would be trying to investigate. Now I do know what the issue is. Which is the same thing that we are seeing here in the warning, which is essentially this needs to be, not that. This needs to be a string, but parse bool here returns a true value or a false value, an actual boolean that's not a string. So what we would do now is correct the problem, which what we need to do is correct this. To correct this problem is, since this is now returning a true value or a false value, which is not a string, we need to wrap this within a string like that, so that within quotes, so that we form a string. As you see, the warning disappeared. But there may be cases where you have no clue, or the linter does not catch your problem, and it would require iterating through making changes, upgrading your application. So here I'm going to promote it, get a second version right there, come here, check for updates. So it would require this kind of cycle of changing, upgrading your application, deploying a new version, seeing whether that fixes the problem, and up until you get to a point where you understand what the root cause is before getting back to the customer. Now I'm going to ignore pre-flights. Again, do not do this at home. Let's see whether the deployment succeeds this time. So these are pre-flights failing. Yes, the deployment did succeed. I expected that. And now we know what the problem is, and we'd go back to the customer and to the customer support bundle, which we looked at here, and figure out, essentially, since we figured out the root cause, we'd come back and we'd go back to the customer, take a look at their release, propose the changes that they need to make, and move on from there. So from this demo, I hope you've gotten to see how we interact with CMX. Now here we have a cluster. Let's exit from this cluster. As we're in the same shell, I managed to create a cluster, which is right here, OpenShift cluster. I do have a few other clusters. So this is a curl cluster, and this is a cluster I created from from my application, which is right there. Yes. Here. So I have a COTS application, and I created that as an embedded. I installed an embedded cluster. Now I use CMX as well to test my embedded cluster setups. So I do have add-ons here, curl add-ons, and at times I try to see whether an installation succeeds or doesn't succeed, depending on the combination of add-ons I have here. Now, there is no capability at the moment or supported capability of SSHing into these VMs, so I still require to use a traditional VM whenever I notice failures. I use CMX to try and install essentially replicated cluster, create distribution curl version, and here you'd have your version number, which is some hash value or an upslug of your curl cluster. I use this to ensure that a curl cluster is deployable, and if it's not deployable, if there are some errors, then I go back to the VM, the regular, the sort of traditional VM setup, and create my cluster there, and use Linux tooling to try and troubleshoot within the terminal. I do use kind at times, but mostly this would be curl, GKE, or cloud provided clusters, or OpenShift. I hope this has been helpful, at least the demo part. Finally, just wanted to have a quick wrap up of some of the value that we've personally have seen of using CMX clusters as opposed to other traditional ways. I've managed to get quicker access of disposable K8s clusters using the replicated same CLI interface. I'm able to create different distros from different providers, be it cloud, be it sort of embedded cluster type of setups, and various versions. As you've seen, you will get all various versions of Kubernetes as well. I have a wide selection of K8s clusters, as I've mentioned, and then this consistent interface. I hope this was helpful, and I hope you enjoy at least using CMX clusters, or find it helpful to use CMX disposable clusters to troubleshoot your applications. Thank you very much.